Hello everyone, welcome to this tree. I plan on making an AI to break the ever so friendly chess.com. For training an AI, I need to make chess because you can't really train an AI to take the biggest chess website on the internet down if you don't have chess. Alright, so that it's easy for me, I will so that it's easy for me to train the AI, I will be making chess from scratch in Python. I will be using Pygame probably. I don't know how to use it. I have never used Pygame before, so let's see how it goes. Alright, so first let's make a main.py which will serve as our driver file, and we'll be needing classes. Let's make a class chess.py. Alright, class chess, and autocomplete is messed up. So this class will contain the driver code. I want to have an enumeration using which we will identify pieces, but as that's not really possible in Python, we will have to use a workaround. Let's make a list self dot pieces. Am I spelling it right? Pieces. Yes. It will contain the list of all our elements of all the chess pieces. Something like, do I want to use strings to identify a piece? Okay, so let me write down what I want to do. Let me open OneNote and let me make a new page. So suppose I have a pawn. I want to assign a code to it, say 0. So whenever I say piece 0, the type of a piece is 0, we will be making a piece class, then that means that piece is a pawn. And for a rook, similarly, if the type of a piece is 1, then that piece is a rook. So I want to assign integer codes to each of the piece. We can go on ahead, a knight having code 2, a bishop with code 3, and so on. And of course we will have a color boolean which will be 0 for white and 1 for black. You know what, let's start with the piece class first, as that seems like it would make more sense. So we have a chess piece. Why I don't remember, do we put a parenthesis over here, but anywho, I'm pretty sure it will give me an error in it. All right, autocomplete is working finally. So self, it will have a type. Let's also take it in as parameter type color self dot color equals to color, and yeah, all right. Next, we have a type, we have a color, and we need to define movement for each piece based on type. All right, let's make a small table over here. Type or piece type upon is going to be 0, rook 1, knight 2, bishop 3, king 4, queen 5. All right, now depth, and of course we want a position. Depth self dot position equals to pos. Position will simply be a tuple of x and y coordinates of that piece on the grid. Next we need move. All right, so there probably is a better way to do this, but for now let's just I think this size is better. We'll just use a bunch of if statements. If self dot type equals 0, and not what I wanted to do. If self dot type equals 0, which is a pawn. Okay, so pawns can move 2 steps forward, 2 block squares forward if they have not moved yet. But if they have moved once, then they can only move 1 step forward. All right, so I can see how the code is starting to get complicated right now. We'll probably need to introduce another boolean, whether a piece has moved once or not. We would be needing this for pawns and for rooks and kings, because castling can only be done if neither of them have moved. And then pawns have this peculiar behavior. They attack diagonally, but they move in a straight line. So Okay, what can we do? Let's say I pass in a variable grid. Now a grid will be a grid object, basically a chessboard. Let's rename this class to chessboard. It will do that work for us. A chessboard. Let's call it board. Now, all right. We'll pass in a reference to the chessboard, and our chessboard will have a function for attacking. Okay, let's deal with has it moved once or not. Let's do self dot moved equals false. If self dot moved is false, uh, then it can move 2 steps forward. All right. And we will need a target position where the pawn wants to move. If it's invalid, then it can't move. All right, so I want to make it such that the target position is always valid, that we don't get, like, we don't want the AI to be struggling to learn rules of chess. We want to tell it the rules of chess. We want it to be good at them. We want it to be good at the game. So what can I do for that? Let me think. All right. So before we finish off this function, let me just write a pass statement over here for now. We write another function, get moves. This function, I forgot the good old self over here. This function will return valid moves which this piece can make. It will take a board parameter. I don't think we will need it in the move function, in the move method, but we'll see. We'll see about that. Self board. All right. So if let's just implement this for a pawn first and test it. If it works, then we implement it for the other pieces. If self dot type is 0, we have a pawn. If self dot move equals false, our board object will have a method to tell us if a particular square is occupied or not. If not board dot occupied, alright, so position will contain x and y, a tuple. I think we should make a 2D vector class, but that would be overkill for chess, I think. Instead of position, I think it would be much easier. Self.x self.y equals position. All right. So let's make moves which will contain the valid moves. Valid moves, let's call it that. If board is not occupied, itself dot x will remain same. It moves up. Self dot y plus 1 valid moves dot append let's make moves. Let's make a list moves, and this will also depend on the color of the chess piece. If self dot color is white, we need to initialize it first. If color is white, then moves, this would be better, I believe. All right, so let's suppose that the top left corner is 0 comma 0. That's the origin. So white, let's say white is on the bottom side, so our board will look something like this. We have all the grids, 3 4 5. All right, 1 2 3 4 5. Well, I don't need to make all of them. So this side would be our white pieces. And alright, bad choice of color. This side, weird. Alright, suppose yellow is black, this side would be black, and this box would be the origin. And this would be actually not 8. 7, comma 7. So if it's white, we'll be going, a pawn is here, to move over here. Let's suppose this is 1 by 1 comma 6. This would be then 1 comma 5. So our y is getting subtracted by 1. And if it were a black pawn, then similarly the y would be increased by 1. So if the color is white, then two potential moves would be these two. -1, else moves would be equal, the same thing, but we would do +1 and +2. Now if self dot moved equals false, actually this simplifies this thing. So it has not moved even once. Alright. So if board not occupied, actually we can do this. Let's get rid of this. If self dot moved is true, so our pawn has already moved once. Then moves dot pop. It will remove the last element from moves, which would be the movement we make. It should be move forward by 2 squares. I'm thinking if there's a better way to do this. I mean, you know what? This is good enough. But as I'm going to use this to train an AI, millions and millions of rounds of chess will be played. Now, I want to minimize operations like here we are adding two elements in the moves list, and here we are removing that element again. And we would be doing this often because it's only going to be true once when in the beginning of the game. So to minimize this, to optimize this and remove this redundant operation of adding into the list and removing it again and again, I will do something like this. If self dot moved is false, then we do this. Else, forgot a column over here. We copy the same code down below. Now This code is much uglier than what we had before. Uh, I removed this. All right. Now this is for sure much uglier than what we had before. But we have the same number of if statements. It's just we are not adding, we are adding to the moves list only when necessary. Else we are not adding into it at all, which is good. So I believe there's no need of this valid moves list because moves would be, oh no, we need, we need valid moves. Now for move in moves. If board, if not board dot occupied at move, then then if board dot, if board is not occupied at move, then valid moves dot append move. All right, and we can then simply return valid moves. All right, so this is the code for a pawn. One thing is left. If the pawn is able to attack someone or not. So if it's a, again, if it's a white pawn, let me draw it in white this time. And here's a black pawn. These are the two attack positions that it would be capable. So going from here to here, we would decrease 1 in x and increase 1 in y, or increase 1 in x and increase 1 in y. So for a black pawn, for this one to attack this one, we would increase 1 in x and decrease 1 in y. Alright, so basically we will have to increase and decrease x by 1 regardless of whether our pawn is black or white. But if our pawn is white, then to attack we will oh no, I just wrote it as backwards. Oops, that's not what I meant to do. It would be positive and it would be negative. Alright. So if a white pawn is attacking, then its y should decrease by 1. X could be either increasing or decreasing. And if a black pawn is attacking, again, x could be either increasing or decreasing, but its y should increase by 1. So if color if self dot color is white, if self dot color is white, then if board dot occupied. So, okay, what are we passing into board dot occupied? A tuple over here, and did we use it anywhere before? No, okay, so let's have it passing tuples. If board dot occupied, but then again, it would pack and unpack. So, you know what? I said I would break chess.com. I did not say I would do it very fast. So, let's use tuples. If board is occupied at self.x minus 1, what I see is that we are doing a repeat of this whole thing. The only difference is we don't have this knot down below. So, is there any way that we can cobble this up into a function? But again, each piece have different valid moves. But there are some repetitions, like you combine a bishop and a rook, you get a queen. There is that repetition. Okay, we'll look into automating that one when we get there. So, but for now, let's deal with what we have got. I see myself doing the exact same thing. Again, over here, we'll just change the moves variable. If moves is self.x, okay, -1, y -1, self.x plus 1, y -1. Else, if the color is black, then y plus 1, y plus 1. For moving moves, if board dot occupied, valid moves dot append move. So we will return valid moves. All right. We have logic implemented for a pawn. Now, I believe we should test this. We should test it for each piece. And let's move on from the pawn code only when we have verified that this works. Now to test it, we'll need to make a chessboard. So, all right. Self-taught pieces. Let me copy this over here. Not what I wanted to do. So, is there any way that I input 0 and I get pawn? I can see I can put P, R, K, B, K, G, Q as strings in a list, and that's basically what we have got there. Type would be index of that. But that's not something I really want to do because I don't see how that would be beneficial to me. The whole point of using integers is to use less memory and have have fast operations. If I put them in a list with P, R, K, B, K, G, K, we'll get multiple strings, which dealing with strings is not very fast. So actually, you know what? I can just refer to this cheat sheet over here and have my whole code based around it. It would be very bad, but it would be fast. All right. I hope I do not regret this. But all right. Let me just throw everything I just said out of window and make a dictionary. Pawn is 0. Rook is 1. Knight is 2. Bishop is 3. King is 4. Queen is 5. So we got that. And import Pygame. I don't think I have it installed. Do I have a Microsoft Store Python installation? Visual Studio. Wait, I am using this one, right? Ah, should not be an issue then. Let's open up a terminal. Pip install Pygame. Alright. Not what I wanted to do. Pygame. Huh. Let me run this code. Why? Why is my VS Code doing this? Alright. A quick restart seems to have fixed the problem. Or has it not loaded yet? Okay, it seems to have fixed it. You have your pieces. And self common self dot board. This will be our actual code and it would be alright, let me do this. -1. -1 would basically mean that a particular box, particular grid is empty. Self dot board -1 for I in range 8 think for for j in range 8. So we have an 8 by 8 matrix. We have an 8 by 8 matrix of filled with -1. All right, that's what we wanted. Now Self-report equals -1. But I don't want all -1s. I want to fill it with pieces. So, oh, but I see an issue with what I have done. Uh, so I was planning to have a matrix which will contain -1 for empty squares, and these codes 0, 1, 2, 0 for a 0 in a square with a pawn, 1 with a rook, but we would also need a way to identify their colors. So how do I do that? Hmm. Okay, there is an easy fix for that. If it's white, then 0 is for a pawn, white pawn, whereas a black pawn would be 0 plus 6, that is 6. A white rook is 1, a black rook would be 7, so on and so forth. Then I would have to change all these. Actually, I won't. I can just do 3, 4, 5, 6. Yeah, there are 6 pieces. I can just add 6. Then we would need to change this code in piece over here. Let's get rid of, let me copy and paste this over here. Let's get rid of the color variable. What are our options right now? So we don't have a color variable anymore. So instead of, I see. Wait a second. We would have to change this from self.type equals to self.type mod 6 equals 0. So it's either 0 or 6. Now if moved, now we would have to change self.color equals 0. That means it's white, to self.type less than 6 means 5. Uh, okay, this is the perfect opportunity. Depth is white. Self return self.type less than 6. Now if self is white, actually function calls are a great overhead, but if we don't use them it would overly complicate our code. Is white, if is white. All right. What else can we do? Okay, I don't think any further changes are needed in this. I have an idea. We can The more and more I do this, the more and more I realize that I should make each piece should have a class. It should be a child of a piece class, which I was trying to avoid from the beginning as multiple. Okay, function overhead is one thing, whereas but class overhead is completely another, and would be playing billions, if not hundreds of millions, might be billions of games of chess, and I don't want that overhead to add up. So I have a choice to make. Should I continue with this, or sh- you know what? Let's continue with this. I don't want to redo this like over again, once again. It's just my laziness. Who cares about good code anyway? All right. Okay, so where were we? We did this function, all right. Chessboard, self.board. All right. Now I can figure out a clever way with for loop to initialize a chessboard, or as I am very lazy, I can simply do this. Just wait and watch. Oh, it's the first one is a rook, black rook, which would be 7. Let me write all of this down. You know what? As this is going to happen only once, I can do this, this for black plus 6. 1 plus 6 is 7. Knight 8, bishop 9. Okay, so king or queen? I think it would be king. Okay, does not matter. We'll change it later. 5. Should be black, so 4 plus 6, 10. 5 plus 6, 11. Then again it would be 9, 8, 7. 0? No, not. Ah, yes, it will be all 0. So pawn 6, 6, 6, 6, 6, 6, 6, 6. All right. We have two these rows. For I in range 4, self dot 4 dot append -1 for I in for j in range 8. So 4 rows of -1 with nothing, and then 2 rows of for I in range 2, self dot board dot append. Actually, let's do it from 1 to -1 with a step size of -1, a reverse for loop. I would take the values 1 and 0, self.board.append p or type -6 for type in self.board I, and just to test it, if I print self.board, let's see what we get. B is equals to, alright, from chessboard import chessboard, B is equals to chessboard. Let's see, what do we get printed? Ah, let's format it nicely. Print I for I in self.board. I don't think this is valid list comprehension, but let's see what happens. Oh, so I meant to run this. It did work as expected. 789. All right, 000 1 2 3 4 5. Is it correct? Pawn. All right. Rook, knight, bishop, king, queen. 3 to 1. Yes, it is correct. It is correct by all means. So there we have it, an internal representation of a chessboard. Let's get rid of this now. We don't need it. Next thing, we can use this command line thingy to debug, but I think that would be very inconvenient. So instead, let's get started with Pygame. So in the rest of this stream, we will be making a chessboard using Pygame and having all the pieces display on it. We'll download sprites, copyright free, royalty free sprites. We will use them, and that would be it. That would be it. And of course, we would get it all to display using Pygame. And then we will be ending the stream. Yes, let's go. So, how to draw square using Pygame? I actually don't know how to do this. Huh. Hold on, I should Google Pygame reference docs. Draw a rectangle. I have checked, but none show. Wait, is there not a function to draw a rectangle? Okay, it seems like there is. Pygame.net. Display equals to pygame.display.set mode. Okay, I'm guessing this is the screen size. 0 to 32. I don't know what this is. We define white and blue colors, standard RGB. Alright, display.fill it with white. Okay, pygame.draw rectangle on display with color blue, and I think these, okay, these can be two things. This might be the top left corner and the bottom right corner of the rectangle, but that is clearly not the case, as this point is certainly right and below of this point. So I think this is let me zoom in. This is the top left corner of the rectangle, and this is the length and the width of the rectangle. Let me see if I am right. You know what? I'm going to go out on a limb and say that I'm right over here. Oh no, wait. While true for event in pygame.event.get, if event.type equals to good pygame.good sys.exit. Pygame.display.update. I think this is standard Pygame driver code. We will be needing it. So hippity hoppity, your code is my property. I'm pretty sure this is available somewhere in the docs and is open source. This seems pretty standard. So yeah, let's make a def draw function which takes in cell and put it in there. Good. Why is it undefined? Pygame.locals. Got it. From pygame.locals import everything, and let's also import sys. So right, for event in pygame.event.get, I think pygame.init adds an event in pygame.event. So we also need to knit something. All right. So what's the function? Pygame.display.set mode. So let me call it screen. Pygame dot missing module. Not a very good sign. Dot display. Okay, it is not missing. Dot set, was it? Set mode. Okay, I need to look into this. Okay, how old is this? Is it fairly new? 2013. Okay, very old. Updated 2019, but I'm gonna trust it. Alright. The most common this will attempt to initialize pygame modules, not all pygame modules, but this will automatically initialize that. You can also easily initialize each pygame module by, for example, only two. Alright. Modules that are initialized usually have a quit function. There is no need to explicitly call this as pygame. Alright, so this is hot garbage. I think. So we finally have one viewer, and here I am looking at Pygame documentation. I'm pretty sure this is not what we expected. Anyway, I'm just trying to figure out how to draw a rectangle using Pygame. This is my first time using Pygame. We have implemented the driver code for a pawn, and to test it, we have also made a chessboard. This is what we are doing right here. We are using codes for each piece. Pawn is 0, rook is 1, knight is 2, bishop 3, king is 4, queen is 5, and these are all for the white pieces. For black, you just add 6 in all of them. So, yeah, this is what we are doing. And I'm using this very not intuitive way, and I'm not using a separate class for each of these pieces because I want to train an AI on this, which would mean hundreds of millions, if not billions, of chess games played. And there is a big class overhead. So I want to avoid that in these millions of iterations. That's why I'm using this something from C era in Python. I know, not very intuitive, but it is fast. And I need fast right now. Pygame dot rectangle. Like I said, it just takes in size. Alright. Pygame display mode, it just takes in size of the canvas. So I'm so excited that we have a viewer. That's so great. Thank you so much for joining me. The size, alright. I should probably make a variable, but as I'm just testing for right now, let's make a 500 by 500 screen. While true, okay, this is an example. Oh, so it is needed. It is not hot garbage. Hippity hoppity, your code is my property. So, alright. I think this must return some list which would contain all Pygame events. And if we get a good event, then we exit. Makes sense. Makes sense. Okay, I just want to display a window. Will this display a window? Can I do b dot draw? Let's see what happens. I have no clue what's gonna happen. Ah, it did display a window. That's great. That's what I wanted. Now here's the ah Pygame object for storing rectangular coordinates. Okay, but how do I draw it? I want to draw it. Left top, width height. Okay, what did they? Dot draw dot back. Okay, let me look into this. Let's just draw a sample square for now. Pygame dot draw dot huh. Yeah. Let's fill it in. Like it's 500 by 500, right? Let's do the top left at 200 and 200. Let's have 100 width and height. So the middle 100 pixels of the screen. And how do I assign color? For color, I think, do they have something? Do they have something? Display dot fill. I think this must be background. Oh, dot draw rect takes in. Makes a lot of sense. And makes a lot of sense why they have this rect object, because all right, you know what? Let me try something. R equals rect. I should probably do. Okay, is it already imported? How is it the most place type? This, draw it on screen with, let's draw it in white. Can I do this? Let's hope I can. Yes, I can. We got a rectangle. Now we need 64 of them. So, all right. This is where we'll start needing constants for screen size. All right, let's have something like screen. I'm just going to write width. Probably should do it before this one. Width. Let's do start. Okay, I want it to be square. Okay, we're making chess. We don't need width and height. We just need size. It's going to be square. So we had 500 by, okay, it's too small. Let's do 800 by 800, really? Let's do size, size. All right. Now, okay, let me look at the documentation again. So we are loading everything beforehand, and in the while loop, the driver code is present. So I don't need to put it in this for loop. All right. So before we start, before doing this in the while loop, let's find out the coordinates of all the squares. Now square size, this will be a constant. Square size, it would be size divided by 8, as we have 8 squares. Now square positions, let's make a list for I in range. Eight for j in range 8. Square positions dot append Actually, let's not call it square positions. Let's call it squares. Or is there a Pygame object? Like, you know what? Let's just make them. Oh no, let's call them squares. And I was thinking of appending a tuple with the x and y coordinates of each square. But we can do what we can do is that we can directly append rectangle objects into this list. All right. So we are basically looping over where each box should be. So 8 times across and 8 times across horizontally and 8 times across vertically. And we're going to put I. Okay, let's do I shape square size I times square size and j times square size. This will result in a chess-like grid. I think it should. Alright. Now over here we can do for I in range. Okay. We're going to use a range based for loop. Range of length of squares. You'll see why I used for I in range of length of squares instead of for square in squares. You'll see it in just a moment. If I mod 2, if I mod 2 is true, that means we have an odd number. Okay, how does a chessboard look like? You go to chess.com. Is the first square okay? The first square is a white one. All right. So then we should have black. So each odd square, and instead of I, let's do squares I. All right. Else, same thing, but we just make it white. So let me explain what's happening in this for loop over here. We are iterating over all the indexes of the elements in the squares list. Now, if the index of that element is odd, then we make its color black. So the first square would be this one in the top left corner. So it is white. The next one is black. So index 0, even index, white. Index 1, odd index, black. Index 2, even index, white. Index 3, odd index, black. You see the pattern over here? That's what we did right here. Now let's see if it works. Okay, it did work, but no, it did not work. Because, okay, why did it not work? Let's see. Ah, I see. Okay, so first of all, it's not like 0, 1, 2. It's more like 0, 1, 2. So we are going downwards as the index is increasing. So 8, 7, 8. So, okay, it works for one row, but for the next row, we need to alternate the colors again. All right. We can remedy it by if I plus 1 and mod 8 equals 0, then huh, then we need to switch them up. At odd index, we need to draw white, and at even index, we need to draw black. So we need to switch them up. How can we do that? Huh. Hmm. Oh, it's easy enough. Let's do it out here. We make with along with all the constants over here. Color 1, which would be, we are using black and white right now, so let's use the color 1, and color 2, which would be black. So color 1, wait, color 1 is white. All right, so it would be color 2, color 1. So initially, if we have an odd index, we use color 2, which is black, and if we have an even index, we use color 1, which is white. Now, if I plus 1 modulus 8 is 0, that means that we have traversed through one column of our chessboard, and for the next column, we need to interchange these two colors. So we can simply do color 1 comma color 2 equals color 2 comma color 1. So what was previously assigned to color 2 is now assigned to color 1, and what was previously assigned to color 1 is now assigned to color 2. And if we run this, it's strange. The Pygame window is getting the R Studio logo on it. Might be some bug. Or does Pygame use R somewhere? I don't think it does. And there we go. We have a good chessboard. Alright. So the last thing that we do before finishing off today's stream is going to download some sprites from the internet and put them on a chessboard. So off we go. Back to Googling again. I will need this. These dots, so I'll keep it opened up. All right, so now we have to download sprites. Just copyright free sprites. Okay, we want 2D sprites. I think this is good enough. Okay, so these have a nice pixelated look to them. I'm not sure if I want that pixelated look. Now let's go for something a bit modern. No, too cartoony. So my sole viewer, if you would like to give your opinion on what should we go with, modern or pixelated, in the chat, would be really glad. But if you don't want to do it, you're just like, all right, I'm the only person watching this guy. I'm not going to give you chores. Please keep watching. That's all I ask. Oh, these look good. A nice blend between modern and pixelated. Are these the same ones that chess.com use? I think chess.com use very similar ones, right? I'm using a custom one. Okay, they're not the same. Not the same. I think this shall work. An improved Kubernetes chess set with a police mutiny, modified knight, bigger king, rook with consistent line, rook. Black is now exact opposite colors. Pawns are slightly less tall. Okay, okay, alright. Copyright attribution. Oh, so open game art. FAQ. Being derived from those to stand fairly. So there seems to be some legal issue with it, but okay. So apparently, I'm not really good at copyright law, but from the discussion, it seems that this license is all right. And let's go to the FAQ. How should I? Yes, you can, even in the commercial projects. All right. So this website is for open art. All right. It's opengameart.org, of course. It's for open art. Just be sure to adhere to license terms. Artists often indicate how they would like to decorate in the create attribution notice section. File licensed, for example. Yeah. All right. CC by SA 3.0. Because to release any modifications you make to the artwork in the question under the same license. All right, the chess AI that I'm making will, once it's done, or even before it's done, I believe, I will upload it on my GitHub under the same license. Let's. Okay, so we'll be uploading sprites over here. Let's just make this thing